Hi, this is Mr. Kreisler. So today we'll be discussing average velocity from our unit 2. So we need to remember our difference between speed and velocity. Speed, we should know, is distance over time, while velocity is displacement over time. So remember from our last lesson, where distance is just the total amount that you traveled, while displacement depends on your frame of reference, or for argument's sake, where you start. To calculate our average speed, we just take our total distance divided by time. And to calculate velocity, that is our total displacement divided by time. We'll get some practice problems with that. Constant velocity means we're moving at a constant speed, direction, nothing's changing, it's constant. Average velocity, on the other hand, we're just taking, well, the average. So we find wherever we started versus where we stopped, we find that displacement, we see how long it took, and that is our time, and we calculate based on that. So for argument's sake, if you were to, let's say, run around the block, and then you stopped where you started, your displacement is 0. Therefore, your average velocity is also 0 because you stopped where you started. Things like that. Let's move on to some practice problems. So in a drill during basketball practice, a player runs the length of a 30-meter court and back. The player does this 3 times in 60 seconds. What is the average speed of the player during this drill? So we have to remember that average speed is equal to total distance over total time. Now, what would be our total distance here? We know that the whole length of the court is 30 meters, but he runs the 30 meters, and then he runs back. So to go back and forth once, that is the 30 plus 30 meters. He does this 3 times. So we can say 30 plus 30 is 60 meters. And he does this 3 times, so times 3. So our total distance would be the 30 meters times 3, which is 180 meters, and divided by the total time, which is 60 seconds. We divide these two to get our average speed of 3 meters per second. So that is our average speed, total distance over total time. Let's try this problem. A baseball player runs 27.4 meters from the batter's box to first base. They overrun the first base by 3 meters and then return to first base. Compared to the total distance traveled by the player, the magnitude of the player's total displacement from the batter's box is, so we need to compare the distance to the displacement. So we're seeing that there's 27.4 meters between home plate and first base. But then the person keeps running for an extra 3 meters before they turn around and come back. So in the first case scenario, we want the 27.4 meters. We pass first base, and then we come back. So that'd be an additional 3 meters. So that means our distance is equal to all of these added together, which is 33.4 meters. Let's compare this to the displacement. So if we're talking about displacement, we're talking about our frame of reference, or our starting point, which is the home plate, and we end on first base. We don't care that we were in passage, where we start, where we ended. We know the distance between these two is the 27.4 meters. So displacement is just 27.4 meters. So we're comparing distance to displacement. So if you were to subtract the two numbers, we would know there is a difference of, well, 6 meters. So the displacement is 6 meters shorter than the distance. So it would be choice B. Let's try this example. A high-speed train in Japan travels a distance of 300 kilometers in 3.60 times 10 to the 3 seconds. What is the average speed of the train? Now we know average speed equals total distance over total time. Now we could simply say 300 kilometers divided by 3.6 times 10 to the 3 seconds, but generally we want things in meters per second. So first things first, going back to our previous lesson, we're going to convert kilometers into meters. Now, we should know from our picket fence method that the original unit goes in the top left of our picket fence, and then we have to convert it. We want it in meters, and we should know easily how to convert kilometers into meters by now, hopefully. If not, refer to your reference table, and we should know that our base unit are meters. There's 1,000 meters, or 10 to the 3 meters, and 1 kilometer. Multiply the top, multiply the bottom, and divide. Cross out opposite units from top to bottom. And we should find that there are 300,000 meters. Now that we converted and we have our distance, we can say our total distance would be the 300,000 meters divided by, we don't have to expand this if you don't want to, just be careful on your calculator to leave this in parentheses, 3.60 times 10 to the third seconds. Divide this out to get your average speed. And we will find that our average speed is 83.33 repeating per meters per second. The most important thing about this problem is remembering that we use meters per second for speed, whether it's average speed, constant speed, velocity, or average velocity. So convert, take your total distance, and divide it by total time. This will be our last example problem for this video. If you do have any more questions, please ask them in class. As always, take down notes, rewatch videos, and come to us with questions. An object on a number line moved from x equals 12 meters to x equals 124 meters and moved back to x equals 98 meters. The time interval for all the motion was 10 seconds. What was the average velocity of the object? In this example, we are talking about average velocity. Unlike speed, velocity is displacement over time. If you're having trouble visualizing this, I'm going to draw an example of what this looks like. So if I'm on a number line and I'm starting at 12 and going all the way to 124, and then I come back to the 198. So we have to remember in displacement, it depends on your starting point versus your ending point. In linear, it's very easy to see. If I start at 12 and then I end at 98, well, how many meters would this be? I would just subtract the two distances. So 98, our ending point, from our starting point, which ends up being 86 meters. 86 meters is our displacement. To find our average velocity, I would take that displacement of 86 meters divided by our time of 10 seconds. We will get an answer of 8.6 meters per second. So 8.6 meters per second would be our final answer for our average velocity. So our displacement divided by our time. So just to recap, we talked about speed, velocity, and we learned the difference between the two and how to calculate them. For our average speed, we should know it's our total distance divided by the time elapsed, versus velocity has to do with the displacement divided by time. And displacement is based on our reference point, so where we start versus where we end, and the measurement between those 2 points. If you are still confused by anything that's been covered in this video, please write down your questions and bring them to class. We will help you out in person. Have a good day.